Hello, and welcome to episode 4 of our open online course for Einstein Summation Convention. In this video, we'll be finishing off our understanding of indices in Einstein Summation Convention. Our aims for this episode will be to know how to apply dummy variables to tensors in order to remove ambiguity within a term, and to fully understand the properties of an equation in Einstein Summation Convention. So, let's begin. Remember last time we showed that a tensor, or a group of tensors, that went through the process of a scalar or dot product resulted in a scalar? Well, that means that we can temporarily consider, say, AII as lambda, because they're both just scalars. But now, consider another product of two tensors, BI, BI, and rename it mu. So what happens if we multiply mu by lambda? Well, let's have a look. Lambda times mu is equal to AI, AI, BI, BI. Now remember what we said in the last video. This is illegal. Einstein's summation convention states that an index cannot appear more than twice within any term. So, is lambda times mu possible? Well, yeah. Because lambda and mu are both numbers, times in lambda by mu would just give you a number to finish. All we need to do is consider what mu, for example, is trying to achieve. So let's have another look at mu. Mu is equal to BI, BI. Remember that BI, BI is supposed to be shorthand for B1, B1 plus B2, B2 plus B3, B3, where the two instances of I indicate a summation. Because of this, I is only temporary, as it is just a placeholder for I is equal to 1, 2, and 3. So there's absolutely nothing stopping us from replacing I with another letter, for example, J. This one simple step completely removes our issue. Let's take a look at our revised mu. BI, BI represents the exact same thing as BJ, BJ. So, now if we multiply lambda to mu, we get lambda times mu is equal to AI, AI, BJ, BJ. This is perfectly legal and very similar to an example of a compound scalar product that we saw in the last video. So in this example, both I and j are dummy indices. Simply put, a dummy index is an index that appears exactly twice in one given term of an equation. Unlike a free index that must appear in every term, a dummy index must only appear once in an entire equation. So, as a rule of thumb, use a different index every time you want to apply the scalar product to a tensor or pair of tensors. Let's have a look at the rules for indices that we have acquired over the past 4 videos. Firstly, free indices must appear exactly once in every term of an equation. Free indices denote the number of components that a tensor or equation of tensors has. Dummy indices must appear exactly twice in one term of an equation. Dummy indices represent a scalar product operation on a tensor or between a pair of tensors. The output of a tensor or tensors with dummy indices applied is a scalar. If more than one scalar product must be present in an equation, a different index must be used for each operation. And lastly, there must never be more than 2 appearances of an index in any term of an equation. Let us consider an example and find out whether it is correct under Einstein's summation. AIIJ is equal to TJ plus BK CKJ plus DMN MNJ. So, first of all, let's have a look for free indices. J appears in every term, and it appears exactly once in each term. So J is a free index. No other index appears in every term, so we must only have dummy indices left if the equation is to be legal. I appears twice in the tensor A, but it doesn't appear anywhere else. K appears twice, once in the tensor B and once in C. That doesn't appear anywhere else either. M and N appear exactly twice in the tensor D and doesn't appear elsewhere. So this equation is valid under Einstein's summation convention. Why not have a go with coming up with your own complicated equations with indices and try to figure out whether they're valid or not? If you have an equation that you're not so sure on, make sure to visit our forum and post your question. Someone else on the course, or one of us, the people running the course, might be able to help you out. If you're still not sure about the purpose of dummy variables, then don't be afraid to have another look at the video, or refer to our course notes if you want a more text-based version of this video. If you want to get some more practice before moving on, but don't want to write your own equations, then have a look at our problem sheets. That's all for this video, and for this half of the course. The next video will be a consolidation video, so if you don't think you're too confident on something, then the next video should be there to help you find out why, and how to improve. I'll see you all next time.